We are to find the real roots for the polynomial function p of x equal to 6x to the fourth minus 23x cubed minus 13x squared plus 32x plus 16. So the job would begin with finding all of the possible factors for the constant term 16, which would be the values here for p. We'd have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And then we would need to find all of the possible factors for the leading coefficient 6, which would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Then all of the possible rational roots for this polynomial would be of the form p over q. So we have plus or minus a half, plus or minus a third, plus or minus a sixth, plus or minus 2/3, plus or minus 4/3, and all we're doing is putting all these numbers over all of these numbers, and then just not duplicating ones that show up more than once. On down here to just the values that we have for p if they were each placed over 1. Now the thing that we'll want to do is choose one of them and do a synthetic division. And we would do that then by putting the minus 1 here and then listing the coefficients for the polynomials, 6, minus 23, minus 13, 32, and 16 we have here. We begin by pulling the 6 down, multiply, write it here, add, minus 23 and minus 26 is minus 29, multiply, write that product here, add, minus 13 and 29 is 16, then multiply again, minus 1 times 16 is minus 16, write it here, add, we're going to get 16, minus 1 times 16 is minus 16, and then when we add these two terms together we get 0, and that's what we're looking for, is a 0 at the end because of the remainder theorem that tells us that if we get a 0 here, then we also have found a root for the polynomial. So at this point, it is factored into x plus 1 times 6x cubed minus 29x squared plus 16x plus 16. And the coefficients for this second factor come from the bottom line of the synthetic division. So now all we have to do is factor the 6x cubed minus 29x squared plus 16x plus 16, and we can do that using our choices of p over q values that we have. And if we choose 4, then doing that synthetic division process again, we get a 0 at the end telling us then that 4 is a root. And then that tells us that the thing can be factored now into x plus 1 times x minus 4 times 6x squared minus 5x minus 4. Now what we have left is a quadratic in our last factor there, so we can just factor that, and our factorization now becomes x plus 1 times x minus 4 times 3x minus 4 times 2x plus 1. This also means that these values are roots for the polynomial. So in other words, negative 1, positive 4, 4/3, and minus a half would be roots for our polynomial. In other words, if we plug those numbers in for x in our original function, we would get 0 for the function value.